honor to be here to show our final demo for the EC551, the Race Master, and all our members are here. I'm Cheng Yang, and this is Yalun Zhang, this is Jialin Zhang, and this is Zhi Lin.
So in our Race Master game, we have 3 different kinds of songs, Liang Zhu, Bella Chow, and Hug. We also have 2 different difficulties, easy and hard.
So let's start our demo.
Now let me demo the game. First we come to the default page. I press enter to select song and difficulties. We have 3 songs. I mean, first select the second song or the third song, whatever you like. And the difficulty is default. The default difficulty is easy. And now let me first try easy. So let's start. Oh, by the way, in the 4 scoring area, we have 4 keys, Z, X, C, Y. You see when I press the key, the LED will be flashing, indicating that which key you have pressed. Now let's start. If I want to pause during the game, I just have to press space, and when I want to resume, press again. I will keep playing. As you can see, the error is 33. When it reaches 40, the game will be over. Let me press some these keys. So now the game is over. When I want to replay, I have to press Q and let me select a different sound, maybe the first one, and hard mode. Hard mode, and the error will falling down more quickly. So. You see, I will miss a lot during this. Now the game is over. And you can also choose to restart the current song during a game. Let me show you. Okay. Now let me show you how to restart a song during a game.
I changed the bus so that which one?
When you want to restart, you just have to press R. You see all the score and error.
I want to
music
chalk it
will
up
start
to
over again.
something funky in our program, but
Well, it would be something good to talk about in your video.
yeah, it's a good point.
Here I set a logic. When there is a long note falling down, you have to keep pressing the key to get extra credit.
Backwards.
If you just directly press key like this,
So at least that's an easy
your
one to fix.
your points will be not that high.
How do I hit it now? I can't see it.
Okay. This picture shows the different frequencies of keys on a piano keyboard. First, I use a basic frequency divided from the main clock, which is 3 megahertz, to generate different scales. And I use another frequency which is 4 hertz for playback speed. And totally in this project, I configured 4 scales from middle C. Each scale includes 7 white keys and 5 black keys, which is totally 48 notes. And since I use 4 Hz for playback, and the shortest note will be a quarter second. For each song, I configured every tone manually, and for maybe for a longer note, I just call it 3 times or 4 times for to make it sound correct. And when the song finishes playing, the play end flag will be set to 1 to drive to put the state into the game over state. And also, when I output different tones, I will give the logic part a 6-bit register to generate different arrows.
So this is the previous diagram we mentioned during the 2 presentations of the game. The audio part is the core part of the game, which gives specific melody to speaker. It also gives a register signal to logic part. Combining these 2 parts, we get what we want from keyboard controller, and we get what can see from the VGA monitor. So this is our final logic block diagram. Specifically, we have 4 Hz clock from the audio part, since it appears 4 notes at 1 second at different notes refer to different values of register melody. Then we refer to melody's value to enable lines of arrow. We will talk about the specific logic part combining with VGA and keyboard controller later. This is the whole logic module calling VGA display because we combine the logic part with the VGA controller. Left red box shows all the modules we have in the logic part. The audio arrow parts combine audio parts to logic parts. The clock dividers help to fulfill scoring function and the speed of moving arrows. Scoring parts help to do the calculation and testing functions of the game. The 6-bit register melody is the input we get from the audio part. All the variables beginning with letter C came from keyboard control at input. Variables R, G, B, HS, and VS are the output coming from VGA controller. The game over flag tells whether the game is ended or not, and the CL key is a 100 MHz clock. And this is the audio arrow path. Each value of the melody is connected to different value of 4-bit register out, which melody's value varies from the RISC, and different values of the out enable different arrows to appear on VGA. And this part is the clock divider part. The clock divider helps to determine the moving arrow speed. As we get a note in the quarter second, we let one arrow goes down in 2 seconds. So we make the clock divider to realize this function by certain calculation. This is the scoring logic part. It is realized by the value of the M, which means the value of V counter from the bottom of each arrow. When we push the button down on the keyboard for a certain line, for example, button 1 is equal to 1, and the certain line arrow is enabled, for example, ran to 0 is equal to 1, we get 1 score. When this line's arrow is not enabled, we get 1 wrong. This is the displaying test box part. When the logic is fulfilled, we get blue color when pushing the button down at the right time with 1 more score, and we get red color when pushing the button down at the wrong time with 1 more wrong. This is the displaying arrow part. When the logic is fulfilled, we display an arrow at a certain line.
Here we will briefly talk about state block diagram, 5 user interface, and VGA logic. First, let's see the state diagram. In our VGA design, we altogether have 5 states. This is the S0 interface. In this welcome interface, the player can press the Enter key on the keyboard. Then it will jump into S1 state. In the S1 state, the player can choose different songs and the difficulty of the game. Here as an example, we choose the third song Hug and the mod Easy. Then it will jump into the play interface. The player can whenever pause, resume, restart or quit the game as they want by pressing the keys on the keyboard. In this S4 state, it is the game over, and the player can also replay the game as they want. Now I will introduce our VJ code for the project. We altogether have 5 VJ surfaces in this project. As we can see, here in F1 is the beginning surface, and F2 is the surface which the player can choose different songs and the difficulty of the game. In F3 module is the surface of the pause, resume, restart, and quit surface. This one, F4, is the game over surface, and the player surface is included in our VJ display module. So here I will take the module frame 1 as an example. We first design the alphabets and the numbers which we want to show on the screen by Microsoft Office Word, and then we change these words into image by MATLAB. Finally, we store this image in this FROM file. So in module frame 1, the color is 8 bits register for output, and the input is H counter, V counter, and clock. Here we set each line, the horizontal and the vertical of these lines as parameters. Then we can set different position of these lines. CC is the status. So here, as we can see, for the first line resume master, we first write this code to show it on the screen. Here is the same for EC551, group eagle, and so on. Then for different cases, we can send different colors. This 8-bit color, the first 3 bits shows color red, and these 3 bits shows the color green. The last 2 bits shows the color blue. So by changing 1 or 0, we can send different colors to the alphabets which we want to show on the screen. And finally, we can show all these words on the screen of the surface. So we're also doing this on F2, F3, and F4 module.